Hey there, this is part 2 of Centres and Mass videos for the Mechanics 2 Edexcel syllabus. Right, so now we have a framework. Loads of people always don't read properly and treat it as a laminar. That is wrong. It's a framework, so it means treat each rod, uniform rod, centre of mass of each rod acts in the centre of the rod, so you've just effectively got a system of particles. So we do exactly what we did in the very first part of the first video. If we're looking at X bar, we've got total mass of 24, so we've got that is equal to the moment along here of this, which is 2 times 1. This is 2 times 3. This is 2 plus 2.5 is 4.5 times 5. This is 7 distance times mass of 2, a 3.5 distance times then mass of 7, and a 0 distance, so we don't include it. And all of that malarkey gives us 2.875. Here we do exactly the same. This is wrong. This 2, it shouldn't be, it should be 2 point something. Anyway, okay. So what we have here is exactly the same again, 24, we've got 2.5 times 5, this vertical distance times that, we've got 5 times 2, 3.5 times 3, and 2 times 5, and 1 times 2, and 0 for this one because it's acting along there. And working all that out, we get 2 point something. I'm sorry, that is a complete mess, but I'm not redoing the video yet again. But you get the idea. It's all good. Right, this one now, centre mass of these. People get these two confused as well. This is a sector, a uniform sector. This is an arc, like a framework, okay? Now, for this, we have this formula, which should be in the formula book, and alpha is in radians. Now, keep that, right, in degrees, but this must be a numerical value in radians. So what I need to do first is that's 25, so I need to change it to radians. I know 180 degrees is pi radians, so if 180 is pi radians, then 25 degrees must be 25 out of 180 pi radians. Pi is 3.14, so working all of this out, I get this. This value goes here. When working this out, you don't do anything stupid with your calculator, you keep it in degrees. If you change calculator into radians, which you could do, you'd have to put all of that into there and sign it, and then it would give you the same answer. But why would you do that? Anyway, putting these values in here, you get 2.58. Centre of mass of an arc, very similar, easier formula, and we just do exactly the same with the values. Now what you notice here is this 2.58 is just over halfway along. Yeah, it makes sense because you got, effectively kind of more mass, more area there. Hang on, what happened? We have a rogue piece of stuff. There we go. Right. So you've got effectively more area in there, so it's going to be pushed towards here a bit. But here, look at this. This really, in practice, is about there, which makes sense because you've only got the rod here, and the centre of mass of it is going to be about there because there's nothing over here. Nothing. Random as a video. I like this. You'll be able to comment on it, and then I'll know you've actually watched it. Right, find the angle something makes when hung. This can confuse people. In the exam, what you could do is just gently kind of hang your paper, lift your paper up a little bit to try and get your head around this visually if you need to. Don't start waving your paper around or anything, or you'll be in trouble. Right, okay, it's hung. When it's hung, we know the centre of mass acts directly below that point it's hung by, okay? So, we worked this one out earlier. This was in a previous video, and we found that was 2.75, that was 1.75, the coordinates of centre of mass. So all we do is write it on here. We're trying to find that angle there, so it's arctan. Job done. Here, Yes, because of issues in transferring the shape, I had to use the same one. So it's going to be quite a steep. I was trying to angle this to get the centre of mass to be directly over the point. When we've gotten the point of toppling, if you take a vertical line down from the centre of mass, the second that that vertical line goes outside of where the shape is touching the plane, the shape will topple. Okay, we're ignoring all the resistance malarkey and everything in Mech 3. You look at whether it will topple or whether it will slide, which is much more realistic. So all it is about if centre of mass vertically comes outside where the shape is touching the plane, it will topple. So you do on the point of toppling. Again, we know the distances from earlier, so we're just doing arctan again. We know that's theta, we know that's 90 minus theta, that's 90 minus theta, that's 90, that must be theta. Boom. Well, thank you for watching a very random video from a very tired young man. Goodbye.